So today we will be deploying layer 2 applications. Deploying layer 2 applications involves careful planning and execution. It is crucial to select the right deployment strategy to ensure scalability, security, and efficiency. This involves understanding the specific requirements of the application and the network environment. Deploying on layer 2 offers several advantages. It allows for high-speed communication between devices, which is essential for applications that require low latency. It also provides greater control over network traffic flow, enabling better security and performance. Here are benefits of deploying on the layer 2. It helps in increasing scalability. Layer 2 solutions provide a significant boost in scalability. They can handle a large number of transactions simultaneously, reducing the congestion on the main chain. This allows for faster transaction processing and smoother user experiences, even during peak periods. This scalability is crucial for applications that need to handle a large volume of users and transactions. It also helps in lowering the transaction fees. Layer 2 solutions offer significantly lower transaction fees than the base layer. This is because they process transactions off chain and batch them together before submitting them to the main chain. This reduces the burden on the main chain and results in lower gas cost for users. Lower fees make layer 2 deployments more affordable and attractive, especially for applications that require frequent transactions. It also gives us an enhanced user experience. The benefits of increased scalability and lower fees translate into a better user experience. Users can enjoy faster transaction confirmation times and reduced costs, leading to greater satisfaction and engagement. This can be crucial for attracting and retaining users, especially in competitive markets. Now we'll look at choosing the right layer 2 solution. 1. Optimistic rollups assume that transactions are valid and batch them together. They're cost effective and have fast confirmation times. However, they require a fraud proof mechanism for security. ZK rollups. ZK rollups use zero knowledge proofs to ensure the validity of transactions. They provide high security and scalability, but they are more complex and require specialized tools. State channels allow two parties to transact off chain and settle disputes on the main chain. They're ideal for applications with frequent interactions between a small group of users. Sidechains are independent blockchains that run parallel to the main chain. They offer greater flexibility, but might not be as secure. They are useful for applications that require specific functionalities. So here is setting up the development environment for deploying our layer 2 solution. So first we install node.js. As we know, node.js is essential for running JavaScript based tools. We install it, the latest version from the official website. We use npm to manage dependencies for our development environment. We then choose a framework. We select a development framework that aligns with our project's needs. Truffle is a popular choice for building and deploying smart contracts. Hardhat is another widely used framework offering excellent testing and deployment features. And then we finally install Layer 2 SDKs. We install the necessary SDKs for the Layer 2 networks you'll be deploying to. These SDKs provide specific tools and libraries for interacting with the network. They simplify the process of deploying and managing applications on these networks. Install the SDKs from npm. We shall look at creating a new project. So creating a new project is the first step in deploying a layer 2 application. This involves initializing a new project directory and setting up the necessary files and folders. You can choose from popular frameworks like Truffle or Hardhat to streamline the development process. The framework you select will determine the structure and tools available for your project. We first need to initialize the project. We start by creating a new directory and initializing a Truffle or Hardhat project within it. We can achieve this using commands like truffle init or npx hardhat. These commands will automatically set up the initial project structure with essential files and configuration. Let us look at the project structure. A typical layer 2 project structure usually includes folders for smart contracts, migrations, tests, and configurations. These folders contain the code, deployment scripts, and testing files for our application. The exact structure might vary depending on the chosen framework and project requirements. Then we install the dependencies. These dependencies often include libraries for interacting with the layer 2 network, developing smart contracts, and testing our application. You can manage these dependencies using package manager like npm. The next step is writing smart contracts for layer 2. We need to craft smart contracts that seamlessly integrate with layer 2 solutions. These contracts must be optimized for scalability and designed to work harmoniously within the specific layer 2 environment. A well structured smart contract will ensure smooth operation and maximize efficiency within the chosen layer 2 network. To achieve this compatibility, developers must consider the unique characteristics of each layer 2 network. Factors like transaction speed, fee structures, and security mechanisms can all influence the design and implementation of smart contracts. Prioritizing best practices for gas optimization and efficient code structure is essential for maximizing performance and minimizing cost. So here we have an example code, which is a Solidity contract. Here we have a deposit function, which basically helps us to deposit some money inside the blockchain. And then we have the withdraw function, which checks whether the balance of the user is greater than the amount required. And if it is, it sends the amount. Now let us look at deploying it to a testnet. We first need to compile the contract. This converts the Solidity code into bytecode that can be executed on the blockchain. We can use the truffle compile command in our terminal. This will generate the compiled bytecode and ABI for our contract. Now, we need to deploy our compiled contract to a testnet. This allows you to test the functionality of your application in a live environment without risking real funds. We can use the truffle migrate command with the appropriate network flag. For example, truffle migrate network Ropsten will deploy the contract to the Ropsten testnet. Then we test the functionality of our deployed contract on the testnet. We send test transactions to verify its behavior and ensure it aligns with our expectations. We can use various tools like Remix or Ethers.js to interact with the deployed contract. We will need to acquire test tokens or use a faucet to fund our testnet account and perform transactions. Now let us look at integrating it with layer 2 networks. First, we need to set up the connection. So connecting to a layer 2 network involves setting up a connection to the network provider. Use the appropriate library for the chosen layer 2 network, such as the Optimism provider or ZK Sync provider. Once the connection is established, you can interact with the network and deploy our application. Then we check the example networks. Two popular layer 2 networks are Optimism and ZK Sync. Optimism uses optimistic rollups to achieve high throughput and scalability. ZK Sync leverages zero knowledge proofs to enhance security and privacy. Both networks offer unique advantages, and the choice depends on our application specific requirements. Then we will be using the provider. Once connected to the network, we can interact with the layer 2 network using the provider. The provider object enables sending transactions, querying the network state, and accessing other essential functionalities. Using the provider, we can interact with smart contracts, manage accounts, and monitor the network. Oh, the first two lines of this code imports the Ethers library for interacting with Ethereum-like blockchains and the Optimism provider from the at ETH dash optimism slash provider package for connecting to the Optimism network. Then we create a provider for the Optimism network connecting to the Optimism mainnet using the specified RPC URL. Then the const signer line attempts to get a signer from the provider. A signer is an object that can sign transactions and messages on behalf of an Ethereum account. Now let us look at deploying to optimism. So first we set up our environment. We have to ensure that Node.js is installed and we must install the Optimism Provider package. Then we configure the project settings. We define the network in our configuration file and provide the Optimism endpoint and credentials. Then we deploy our contract. We use the Optimism provider to interact with the network and deploy the contract using a contract factory and wait for deployment. Then we verify deployment. We confirm deployment success and retrieve the contract address. Then we interact with the deployed contract on the Optimism network. In this code, we first import the Ethers library for interacting with Ethereum-like blockchains and the Optimism provider. Then we define an asynchronous function to deploy the contract. This function attempts to create a provider for the Optimism network and get a sign-off from it. Then we create a contract factory and we deploy the contract. So Ethers.contract factory creates a contract factory with the provided ABI, bytecode, and signer. Factory.deploy deploys the contract and await contract.deployed waits for the contract to be deployed. Then the console.log logs the address of the deployed contract to the console. Now let us look at deploying to ZK Sync. So ZK Sync is a popular layer 2 solution that uses zero knowledge proofs to enhance security and scalability. It provides a secure and efficient way to deploy smart contracts, enabling faster transaction speeds and lower costs. First, we set up the environment. We ensure that Node.js and the ZK Sync provider are installed. We configure our project settings to include the ZK Sync network endpoint and credentials. We then deploy our contract. We use the ZK-Sync provider to interact with the network. Then we deploy the contract using the ZK-Sync network and wait for deployment to complete. Then we verify our deployment. We confirm that our contract is successfully deployed. Then we retrieve the contract address and interact with the deployed contract on the ZK-Sync network. So here is an example. First, in the first two lines, we are importing the necessary libraries required. Then we are creating an asynchronous function to help us deploy the contract and get a signer. Then we are creating a contract factory to help deploy our contract. Then finally, we are logging the contract address to the console. Now let us look at handling transactions on layer 2. First, we'll look at sending transactions. So sending transactions on layer 2 network involves interacting with smart contracts deployed on the network. Transactions are sent using tools like Web3 libraries or APIs provided by the Layer 2 network. We need to provide the necessary information for the transaction, such as the recipient address, amount, and gas fees. Then, receiving transactions. Receiving transactions involves listening for events emitted by smart contracts on the Layer 2 network. You can set up listeners using Web3 libraries or APIs to detect incoming transactions. Once a transaction is received, you can access its details, such as the sender address, amount, and transaction hash. Then we shall monitor the transaction status. So monitoring transaction status involves tracking the progress of transactions on the layer 2 network. We can use APIs or Web3 libraries to query the network for the status of a transaction. This helps to determine if the transaction has been confirmed or if it has failed. So in this example, we first create an asynchronous function named sendTransaction. The first line sends a transaction to the deposit function of the contract, sending 1 Ethereum. Then the next line waits for the transaction to be mined and included in a block. Then the console.log logs the transaction hash to the console. Security is paramount when deploying layer 2 applications. We must ensure that our application and its underlying infrastructure are robust and protected against vulnerabilities. A secure deployment helps maintain the integrity of our application and safeguards against potential attacks. This is essential for protecting user funds and maintaining trust in our application. Leveraging secure coding practices, conducting comprehensive audits, and deploying on robust infrastructure are key to building a secure application. Consider using tools like Mithril to analyze our smart contracts. The command myth analyze will help you identify potential vulnerabilities. This proactive approach helps mitigate risks and ensures the security of our layer 2 deployment using development frameworks. So, development frameworks are invaluable tools for streamlining the deployment of layer 2 applications. Frameworks like Truffle and Hardhat provide a robust foundation for development, testing, and deployment, enhancing efficiency and simplifying the process. So, the benefits of framework are they provide a standardized project structure, essential tools for compilation, testing, and deployment, and seamless integration with popular layer 2 networks. They also offer a range of plugins and extensions for enhanced functionality. A common workflow involves initializing a new project using the framework, writing smart contracts, compiling them, deploying to a testnet or mainnet, and then interacting with the deployed contracts. Now, to deploy our contract to the Optimism network using Truffle, we use the command truffle migrate network optimism. This command will use the provided configuration for the Optimism network to deploy our contract to the desired environment. As we have seen before, testing is crucial for ensuring the functionality and reliability of our deployed layer 2 application. Thorough testing helps identify potential bugs, edge cases, and security vulnerabilities before they impact users. So, the first step is writing test cases. We must create comprehensive test cases that cover various aspects of our application. These tests should simulate real world scenarios, including deposit and withdrawal actions, contract interactions, and edge cases. The goal is to test the functionality of our smart contracts. Then we should be running these tests. We must execute these test cases on the chosen layer 2 network. This ensures that our application platforms are as work as expected in the live environment. The test suite should be automated for efficient testing. Then we must analyze the results. We must identify any failed tests and diagnose the underlying issues. This process helps to refine our application and ensure its stability. In this example code, we have written two tests. The first part checks the deposit functions and the second part checks the withdrawal functions sanctity. So we have to monitor the deployed application. So monitoring the deployed application is crucial to ensure its smooth functioning. You need to track key performance metrics like transaction throughput, gas fees, latency, and block confirmation times. This data helps identify any bottlenecks or performance issues that need to be addressed. So we need to leverage dedicated monitoring tools like Etherscan and BlockScout to gain insights into our application's performance. These platforms provide comprehensive data on transactions, contract interactions, and network status, offering valuable insights into the health of our application. Then we need to set up alerts and notifications to be informed about critical events like transaction failures, network disruptions, or performance degradation. We can configure these alerts to trigger when certain thresholds are exceeded, enabling timely intervention and issue resolution. Now we shall look at upgrading and maintaining the application. Maintaining and upgrading our layer 2 application is crucial for ensuring its long-term health and functionality. As our application evolves, we may need to upgrade smart contracts, integrate new features, or address security vulnerabilities. A well-defined strategy for managing upgrades and maintenance is essential. So, first, we should manage our contract upgrades. We must implement upgradable contracts. These allow for seamless updates without redeploying the entire contract. We must ensure proper access controls to prevent unauthorized modifications. Then, we must do continuous integration and deployment. We must automate testing, deployment, and monitoring processes for faster updates and improved efficiency. We must leverage CI/CD tools like GitLab CI or Jenkins for streamlined workflows. Then we must monitor application performance. We must regularly monitor application performance metrics, track transaction throughput, gas fees, and response times to identify potential issues. We must address performance bottlenecks and optimize code for efficiency. Here are some real world examples of layer 2 deployments. So in the DeFi, Synthetics is a layer 2 DeFi platform that enables the creation and trading of synthetic assets. It uses optimism to achieve fast and affordable transactions. Synthetics has demonstrated the potential of layer 2 for building complex financial applications. In the gaming sector, Immutable X is a layer 2 scaling solution specifically designed for the NFT gaming industry. It uses ZK Sync to provide fast and secure transactions for in-game items. Immutable X has enabled developers to create engaging and scalable gaming experiences. In the NFTs, OpenSea is a popular NFT marketplace that leverages layer 2 solutions like Polygon to enhance its scalability and reduce transaction costs. This has allowed OpenSea to offer a more efficient and user friendly experience for buyers and sellers of NFTs. So, here are some challenges and solutions in layer 2 deployment. Handling interoperability. Interoperability between different layer 2 networks can be a challenge. Developers might need to manage multiple integrations and bridge assets across different networks. Solutions like cross-chain bridges can facilitate asset transfers and communication between networks. These bridges can help developers overcome interoperability challenges and create a more seamless user experience. Then we shall manage security and performance. Maintaining a secure and performant environment is crucial for layer 2 applications. Security vulnerabilities can lead to asset loss and user distrust. Optimized code and efficient infrastructure are essential for optimal performance. Regular security audits and performance monitoring can help identify and address potential issues. Then, the third challenge is ensuring user adoption. Encouraging user adoption is essential for layer 2 success. This requires building user friendly interfaces and providing clear documentation and tutorials. Partnerships with existing platforms and communities can help drive adoption. Providing incentives for users to engage with layer 2 applications can also encourage participation. So, the conclusion is deploying layer 2 applications unlocks significant potential for scalability and efficiency. By leveraging the benefits of layer 2 networks, developers can create innovative applications with improved user experiences and lower transaction costs. To further explore the possibilities of layer 2, consider experimenting with different layer 2 networks and developing innovative applications. Stay up to date with the latest advancements in layer 2 technology and explore emerging tools and frameworks that can enhance our development workflow. Thank you.